I sometimes use CDs in hopes of providing good sound quality to my audience on YouTube. On the other hand, although I own about 3,000 LP records and 2 turntables, I rarely use them except in very special cases. This is because a very groundbreaking method of storing, transmitting, and sharing music in physical or virtual spaces emerged using the MP3 audio format appeared in the 1990s. Finally, after 2015, when high-performance digital audio formats began streaming at affordable prices, I no longer needed analog audio from a turntable. Although many audiophiles have now moved to streaming services that offer formats such as FLAC with lossless compression, there are still quite a few who cannot forget the nostalgia of vinyl records. People who are passionate about vinyl sound seem to have strong beliefs. They express their opinions, such as saying that digital sound is too cold, that something is not natural, and that LP is the best in terms of tone and sound quality. I designed a built-in phono EQ preamp shown in the picture a long time ago for vinyl sound enthusiasts. Today, in addition to the reliable vacuum tube circuit used for this model, I would like to introduce a solid-state moving magnet phono equalizer that can be easily purchased on the market. The output of the moving magnet cartridge is only 2 mV. In the case of the moving coil cartridge, it is only about 1/10 of that of mm. If this extremely low output signal is connected to a general audio amplifier, it will be impossible to reproduce normal sound. The technical interpretation of phono EQ is called RIAA equalizer amp. This is the circuit of the EQ amplifier board introduced today. It is a very simple approach, consisting of only one integrated circuit per channel. On the other hand, this is a vacuum tube EQ that increases output by 50% by connecting 12AX7 and 6SL7 in series. On the left is the standard curve recommended by RIAA. On the right is the response result measured using a vacuum tube type phono EQ. Although there are some minor differences, it is in very good condition. This is a very simple phono EQ board that I purchased from AliExpress about a year ago. The price is around $20. Texas Instruments NE5532 is mounted on a very small double-sided PCB. The operational amplifier NE5532 was first announced by Signetics in 1997 and has been widely used in low-noise audio applications ever since. For today's experiment, 2 inputs, 2 outputs, and 3 power lines were soldered to the electrodes under the board. Because it was temporarily soldered, the space between the electrodes is very narrow, so it looks like the adjacent electrodes will be short-circuited. Just in case, I checked all adjacent electrodes with a multimeter to make sure. I connected the output of the audio generator to the right input terminal. I connected the right output to the input of the oscilloscope. And the output of the audio generator is precisely adjusted to 2 mV to maintain the ideal state. This is to precisely measure the characteristics of this board, assuming a moving magnet cartridge output of 2 mV. Now, we need a dual power supply. Connect the plus, ground, and minus wires coming from the board. Both supply voltages were calibrated to plus 15 volts and minus 15 volts. A small aluminum plate was prepared to minimize noise from the outside. The aluminum plate and the board's ground are connected to each other. As soon as the power is turned on, a signal output of 1 kHz responds. This time, a frequency of 10 kHz was applied. As mentioned in the principle of phono EQ, the output level is greatly attenuated compared to 1 kHz. If this logic is true, the gain at 100 Hz is increased by as much as 15 decibels. Now, let's calculate the total gain of this board when signal input is 1 kHz. The input is 2 mV and the output is 120 mV, so the overall gain at 1 kHz is 35 decibels. The results calculated manually or measured by an audio analyzer are the same. The output voltage when the input signal is blocked, so-called, the internal noise of the amplifier is almost negligible. Total harmonic distortion is 1.5% at the maximum output. This level is not a problem at all in audio applications. Lastly, let's scan the RIAA frequency response, which is a very important technical element. As you can see, this small circuit board reproduces almost the same curve recommended by RIAA from low to high frequencies. Considering the results so far, the characteristics of this board are very excellent. However, I think the big disadvantage is that the gain is only 35 decibels. Furthermore, I think that the low and high frequency sound reproduction characteristics are somewhat unsatisfactory compared to the vacuum tube type phono EQs I have made so far. I prepared a 300B single amplifier, turntable, and phono EQ board. As you can see, the playback sound is very nice, but as mentioned above, you have to turn the volume up almost to maximum to get this level of sound. If you think you don't like the tonal color, you may need a tone control.
2 hours of pushing brooms by.
To supply power to this phono EQ board, a dual power supply as shown in the picture is essential. And this power source must be as far away from the board as possible. If you want to increase the amplification gain to 40 or 45 decibels, you can purchase a board with 2 NE5532 IC as shown in the picture. And the most important thing to remember, you must have a metal case to shield noises from outside completely. Thanks for watching my videos.